All right, trig day number 2. We're going to talk a little bit about identities, and I think arc length and area of sectors. So let's get started. So there you go, circular trig functions in trig. The circle, radian measure of angles, length of an arc, and area of a sector. So here's how you find the length of an arc. Right, S here stands for arc length, R is radius, and theta is your angle, but just recall that your angle has to be in radians. Alright, so conversion factor to go from degrees to radians is multiply your degrees by pi over 180. So if you had 45 degrees and you weren't quite sure that was pi over 4, you'd multiply that by pi over 180. And that would give you pi over 4 when you reduce. Okay, area of a sector. I like to think of area of a sector instead of 1/2 r squared theta. I think of it as theta over 2 r squared. Okay. All right. Find the arc length and the area of a sector for radius 7 and degree 40 degrees. Okay, so I don't want 40 degrees. First of all, I see that. I'm going to multiply that by pi over 180. Which would reduce to, would that be pi over, I think 2 pi over 9. Okay, so if I want to find the arc length of this thing, all right, let's say this is 40 degrees, and I have a radius of 7, then this arc length, the length of that, right, would be r theta. So 7 times 2 pi over 9, which would be 14 pi over 9, which is 4.89, what is it, centimeters? Yep. Okay, so then the area, right, so the area of this sector would be theta over 2, which is 2 pi over 9 over 2, which is 2 pi over 18, times r squared times 49. Alright, so let's get an approximate answer for that. I don't really care about the exact answer. I'm going to get an approximate answer. And I'm getting about 17.104 centimeters squared. Alright, that is arc length and area of a sector. Alright, so I'm not going to go through all the details of the proof of these. Okay, but we're going to go ahead and just define these in terms of sine and cosine. So tangent is sine over cosine. Cotangent is the reciprocal of that. Secant is 1 over cosine. And cosecant is 1 over sine. Alright, a few of the Pythagorean identities. First of all, we know that in the unit circle, right, if we have cosine and sine theta, this is a right triangle, of course, then sine squared plus cosine squared equals 1. Okay, so therefore from that directly we get that cosine squared equals 1 minus sine squared, and we'd also get that sine squared equals 1 minus cosine. Alright, so let's take a look at this. Knowing that the sine of theta equals 4/7 in quadrant 2. Okay, so I'm going to go quadrant 2 here. Sine is 4/7. Find all 6 trig functions. Okay, well, I'd have to find this side. And of course, Pythagorean theorem would tell me that that side, which, let's just call it, well, let's not call it anything. Let's just find out what it is. That thing plus this thing equals this thing. Pythagorean theorem. So x squared would equal 49 minus 16, which is 33. So x would have to equal square root 33. Now be careful, it's in quadrant 2, so it'd be negative. It's not a perfect or a Pythagorean triple, seeing that that's not a whole number. So now what we can do is this here is theta. Right, so all 6 trig functions. Sine of theta we already knew, it's 4/7. Cosine of theta, we can now know negative root 33 over 7. Tangent of theta, okay, would be, what would that be? 4 over, I'm going to just bring that negative up, 33. Alright, or if you decide to rationalize the denominator, that'd be negative 4 root 33 over 33. If you hear the elevator music in the background, it's because I'm listening to some smooth studying music. All I did was multiply by root 33 on top and bottom. So now if I want cosecant, I just take this and I flip it 7/4. It's that easy, you guys. Don't make it difficult. Secant, reciprocal of that. So I'd say negative 7. I'm going to go varsity answer. And then, of course, tangent would turn into cotangent if I flip it over. So I'd have negative root 33 over 4. All I did was flip the first one. Right? Alright, so that's draw a triangle. If you're ever encountering a situation like this where it gives you some value for some trig function in a quadrant, draw a stinking triangle. Oh, identities. I love you. Alright, so you might be fooled into thinking, oh, right, that is cosine squared. And guess what? You'll be really, really sad if you do that. It's not going to help you much at all. Alright, so what I would do is I'd factor it. This is a difference of 2 squares. If I had x squared minus 9, that would be able to be equal to x minus 3x plus 3. I think you know that. So, with that being said, this is also a difference of 2 perfect squares. Square root of 1 is 1. Square root of sine squared is sine. So I have 1 minus, 1 plus. And look at that. We're going to get some cancellation. So it looks like our answer would be 1 plus sine alpha. Similar here. I don't know why this says 2 minutes. Maybe that's the amount of time it'll take you to, I don't know, run a third of a mile. Cool. Okay, so let's factor the numerator. It's a difference of 2 perfect squares. That'll be cosine of this thing phi minus sine of phi times cosine of phi plus sine of phi. Oh, such a great cancellation. Cosine of phi minus sine of phi in the denominator. Should probably put parentheses because some of you type A children are going to get upset at me. Alright, now we get another cancellation. Cool. The answer is cosine of phi plus sine of phi. Let's try another one. Ooh, sine squared over cosine squared. Ha! How about tangent squared? Cool. Okay. 3 sine x plus 2 cosine x tan x. Probably my greatest tip when simplifying anything trig related. Write everything in terms of sine and cosine if you don't see an identity. Because things tend to cancel. So I got 3 sine x and 2 sine x. So 3 sine x plus 2 sine x is 5 sine x. Cool. Find the arc length and area of a sector of radius 5 and angle 2 radians. Oh, that's nice. So arc length S equals r theta. Why did I say that's nice? Why? Because it was already given in radians, so the arc length would be 10, what is that, centimeters? Area, theta over 2, 2 over 2, r squared, 25. Looks like the area would be 25 centimeters squared. That's too easy. If a sector has a radius, ooh, here we go, of 2x and an arc length of x, okay, so radius, 2x not perfectly drawn, arc length, x, show that the area is x squared. Alright, so it wants me to prove that the area is x squared centimeters squared, so let's do this. Let's take the area formula. I want to use a different color, which is theta over 2r squared And in for theta, do I know anything about theta? No. That's cool. Alright, so I'm going to have to find theta first. That probably means I'm going to have to use arc length here. I know the arc length is x. I know the radius is 2x. I want to find theta. Let's leave theta yellow here. So it looks to me like theta will equal x over 2x, which is 1/2. So I know theta is 1/2. 1/2. Now 1/2 over 2 will be 1/4. What is r? R is 4x. Or excuse me, 2x. So I'm going to take 2x, I'm going to square that. That's going to give me 4x squared, and looky there. Looky there, folks. The area is x squared, centimeters squared. Common mistake, you know your formulas and then figure out where you got to go to get to where you need to be. Right here, I would have had 2 unknowns to start with. Should have known it. Not a veteran move. All right, let's keep going. All right, AT is tangent to the given circle. Okay, so first of all, geometry. Hello, if AT is tangent to the circle, that makes this a right angle always. Always. Okay, so then OA is 13, and the circle has a radius of 5. So that makes this length 5. OA is 13. You should see a Pythagorean triple here. If you didn't know it already, that would be 12. 5, 12, 13 is a Pythagorean triple. Find the perimeter of the shaded region. Okay, cool. This is cool. So I like this. So then this would be 5 as well. So that would make this length 8. So really what I'm doing is I'm finding this perimeter here. So all I got to do is, what color haven't I used yet? Let's use gray. I got to find that length, and then I'll have the perimeter. I already have 12 and 8. Just got to find that arc length. That's all it is. So the arc length, S equals r theta. R theta. Well, I don't know the arc length. I do know the radius is 5. What does that angle measure? Oh, that requires a little right triangle trig. Alright, so this is a right triangle. That's a right angle. I got a 12, I got a 13, I got a 5. I want to find this angle. Well, I'm going to find that angle. I'll call it theta. Theta would equal the arc tangent, or inverse tangent, inverse trig, 12 over 5. Okay, and I want that in radians. So I'm going to put my calculator in degree, or in radian mode. I get theta equals 1.176. So 5 times 1.176 gives me 5.88. So that part of the arc there is 5.88 units. What is it, centimeters? Yep. So now here, this gray space is 5.88. I'm going to add that to 20. So the perimeter would equal 25.88 centimeters. All right, that's it for day 2. See you next time. Can you say hi, buddy? You say hi?
Where?
Say hi. Just say hi.
Where?
Say hi.
Where?
Just say hi to the iPad.
No.
Say hi. Say, I love tractors. No? Say something. Okay, fine. Oh, have a good day.